Oh, no.
What's this got to be?
9.
Can you please solve this?
It's gotta be 9.
4.
It's got to be plus 1,
Yeah, 9.
right? So this is 9 equals x. So this number has to be 9.
So it's 4. It'd make it 4.
That would be fun. If you look in your periodic table, the element number 9, let's get used to this. This is the periodic table we're going to be using for the test. The 9 is above the F. Can you see that?
See.
That's where the 9 is. So that makes this side completely even. Let's talk about the top. What's this number got to be? You can just look at it.
Anything. 16.
16. It's got to be 16 because 16 plus 0 is 16. Okay?
Yeah, but what about 8 minus 1 is not 9?
No, 9 minus 1 is 8.
We've got the equal sign right here, right?
Oh yeah.
Okay. Now let's do another problem. Another element. Sasha, pick an element, please.
Gold.
Yeah.
Sasha, can go her voice.
Sodium.
Sodium! Nah! Sodium.
Wait,
Nah.
which you, like, on the side?
Yeah.
Which part is it?
Sodium. I'm just making this up right now.
Is this fission and fusion?
No.
What is it?
Alphabet again.
This is 11.
Equation
This is now giving off. Oh, I'm going to make this tricky. Can I make it tricky? Make it tricky.
Alpha.
It's going to give off both alpha. I'm just making this up. Totally making it up. Alpha, and it's giving off beta. I'm going to say it's giving off both. And what's the remaining element? That's what I want to know. What's this?
Oh, question. Could you break this down sort of like you know how we did that thing with the algebraic expression? So
Yeah. So let's look at the bottom.
yeah. So
So it's going to be 11 equals 2 plus minus
Oh, I thought it was
1
neon.
plus x.
no, it would be neon.
It's not neon?
It would be neon. It would be 10. X equals 10.
So let's solve for this, okay? So 2 minus 1 is 1. So let's do that. 11 equals 1 plus x. Okay, so now solve this.
gonna be
That's 1
10, yeah.
minus 1. 10 equals x. So this
10.
over here has to be 10. Okay? Which element is that?
Neon.
Neon.
That doesn't make sense.
And then the top has to be 19. Mark, how does it not make sense?
Because 10.
Mark, the bottom's all
Now
have
let's
to
take a
equal
look
each
at
other.
the top.
Minus 1.
The top is a little bit easier, right?
Mark, the
Top's a
bottom
bit
has to
easier.
equal
We've
each
got
other. Pretend that
23.
arrow is an equal sign.
Yes.
Equals
So
4
11 equals
plus
2 minus
0
1.
plus x.
No,
Plus
no, no,
10.
no, no, no. Plus 10. 2 minus
See?
1 is 1. Plus 10 is 11.
So
I'm
can
liking
I
this
go
X
through this
then.
one step right here? So let's do 23 minus 4 is, let's do minus 4 on both sides. This has got to be 19 equals x. So this has got to be 19. Okay?
Alphabet.
So that's the right answer.
Still?
I love this algebra thing.
Yeah, me too.
This is my new favorite thing right now.
Except that I
So
hate
that part
right
right
now.
now is given. The one that's in the box is what you have to find.
Exactly. What if I would do something like this? I'm going to mess you guys up.
33 minutes.
This is I'm spending a lot of time on this. I shouldn't spend so much time on this. But let's just say that we have this, and let's also say that this over here is, let's say, carbon. Whoops. Let's say carbon. Let's say carbon, and carbon only has. Oh, let's say carbon only has this, and let's see. How would you solve this?
That would have to.
Boron. Is it not
Boron.
boron?
Yeah, you'd have to add
7.
boron.
It would be 7.
4.
Oh wait, you need 5 more, so you need a boron.
I'm gonna do algebra.
7.
What you guys are saying.
It's
How about
5.
that? How about that?
The bottom
Never
is
mind,
5.
guys.
4. The bottom is 4.
Jokes.
It's 4 and 2. Helium.
Oh no
Wait,
no.
did I say that right? I don't think I did.
You didn't.
It's 5.
Top is 4, bottom is 2.
No, that's right.
You need 2. Helium.
So what goes into this
2.
blank right here?
The bottom's 2.
Yeah.
Oh, 4. X equals
So let's
4.
look at the bottom.
2.
7 equals minus 1 plus 6 plus
Oh.
x.
Might be.
Okay? So what's this got to be?
5.
This is now 5 plus x equals 7. So
Minus
now
5.
minus 5.
2.
So minus 5. And so this is going to be 2 equals x. So this is going to be 2.
The top is gonna be 4.
Top, the same algebra thing.
Yeah. I
Okay,
did
so
it
we go
right.
12 equals x plus 0 plus 8. How that. I know I put the X's in different places. It's
It
okay.
doesn't matter.
Okay. Now we got a -8 on both sides, and the final answer is going to be
You have an alpha particle.
4 equals X.
equals X. This is going to be 4. So now it's enough. Good.
Yay.
Those are the kinds of questions I'd ask. Those are really, those are, as
I
far as
like
you can
them.
get.
Can you put like 50 of those?
They're my favorite,
Let
yeah.
that be the whole test. That'd be good.
That would be nice.
Okay, so that's alpha, beta, gamma. Ionizing, non-ionizing radiation.
Very nice.
What do you need to know about this? Probably the only thing you need to know about this is the Geiger counter. This is a big deal. Geiger counter.
Ionizing and non-ionizing?
Stop, please.
Is that what we're talking about?
You stop.
Come to him.
You stop.
We're,
Here we go.
we're doing ionizing and non-ionizing, right? Yeah.
Ready?
Yeah.
Okay. Here's the ionizing radiation. It's coming in. This is what everybody says. They say the ionizing radiation creates a current in the Geiger counter, which makes it click. Wrong. Giant red marks are going to appear on your paper. That's not right. So you missed a step along the way. I'm just going to go through it. Okay. So as it's ionizing, let's think about what's going on when it's going through the air right here. This ionizing radiation is not just passively going through the air. What it's doing is it's taking electrons off of, here's an atom and here's an electron. Okay, it's taking electrons away. So it's ripping off an electron. It's ripped off this electron. It's now ripped off. And now this, I'm talking about just gas molecules that are alongside of here. Okay, they're just around. This ionizing radiation then rips off electrons, gives it to other atoms and so forth. If it rips off the electron, it creates
An ion,
ions.
which are charged atoms.
So this now is an ion. This ion is then attracted to the side. And if this is a negative ion, then that's attracted to the positive side. The ions create the current, and the current makes the click. Okay? So it's a longer process than a lot of people are saying. People are saying that it's just the ionizing radiation causing the click. That's not true. The ionizing radiation makes ions, which are then attracted to the side of the Geiger counter, which create the current, makes the click. Okay? So it's just one extra step.
So if you do have this question on the test, like if you like, how does the Geiger counter work?
Yeah.
Can you just like draw the picture, then like diagram it to answer? Or do you want like sentence?
You can use it as a diagram if you'd like, unless I ask you to use specific vocabulary words.
Okay.
In that case, you could draw the diagram with the vocabulary words, like
Yeah.
this is an ion, this is ionizing radiation, if you'd like.
I don't really understand the way it works.
Okay, well then just replay the video over and over and over until you remember.
No, because I heard what you said, but it made no sense.
And you can put it in your phone.
Then ask him during a study hall or something.
So that's too broad of a question right now, we need to diagnose what went wrong with that. Okay, so we need to talk about this individually. We need to talk about this individually, but not right now. Okay? Okay.
So, what kind of question would you ask for that?
I'd ask how a Geiger counter works.
And what would you want us to write?
You could draw that exact diagram and write exactly
No, I know.
what he wrote.
I would either say draw a diagram, or I'd say maybe use the following words in your answer, something like that.
Oh, so
And you can do that.
Mr. Sand?
Yeah.
So if I said exactly this, the ionizing radiation creates ions which follow the current and make a click.
Creates ions which are attracted to the edge of the Geiger counter that create current and make a click. That's what it is.
Okay.
Okay? Let's see. But that's not saying if I want you to use vocabulary words, you might have to use vocabulary words in that description.
Got it.
You have to be a little bit more flexible.
Okay.
Not just memorize. Is it still running?
Yeah.
Okay.
I'm gonna put
Fission,
this video
fusion.
on my iPhone. I'll be like,
Fission, fusion. Let's talk about it. Fission, fusion. Fission is when something divides, it's division. Fusion is when something fuses, it comes together, right?
yeah.
Right. So, for a fusion reaction, let's do that one first. Fusion. You've got, let's do H2 plus H3, and then let's say that something plus a neutron comes off. What would this something be?
Oh, wow, I forgot
All this
Isn't
is
it
balanced.
H1 and 1?
this. 5, 2.
So that'd be helium-5.
So how did you find that?
Oh,
This
we're
is exactly
using
the
the
same
elements?
thing.
4 and 2.
Oh, I didn't know we're finding. Okay,
4
we're
and
finding
2.
elements.
Unit.
So we got 1 plus 1 on that side equals
2.
x plus
Oh,
0 on that side. What's x?
2.
Helium
Four.
5.
Who said 4?
Are you talking about the top or the bottom?
Yeah,
Talking
it's
about the bottom,
helium.
sorry.
So that would
Wait,
be
this is
2.
fusion, right?
Yes, this is fusion.
Okay.
So the bottom, 1 plus 1 is
2.
good. 2 is on the bottom. So what element does that have to be?
Helium.
You're right, helium. Okay, now on top, check it out.
4.
We've got, I'm going to do the top now. I'm going to do that one in green.
Oh yeah.
Okay, 2 plus 3 equals x plus 1.
Minus.
X equals 4.
Minus 1, so x has to be 4.
And it's also an alpha particle. What?
Okay, cool. So now we've got that coming together. Now, that's fusion, when something's coming together. Which one has more power, fusion or fission?
Fusion.
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 It would
Why?
have to be because fusion is particles coming together, so it's creating, I guess, a larger particle.
So this is
It's
fusion.
creating a bigger particle.
It's a
But
kaboom versus
but what's happening is that more of this reaction is turning into energy.
Yeah, because there's more.
This is fusion, not fission. Right?
This is fusion. Right? Now, let's talk about fission. This one's harder. That's fusion, this is fission. Fission is division, right?
Fusion, right? The answer was just like, what helium was?
The answer was to find out, yeah, it was just to find helium. That's it.
And that's what you need this part right, the periodic table.
Okay, we got on this side, pick an element. Mark, pick an element.
This is fission.
Nickel.
Nickel, good. Nice choice. Nickel, I like nickel. Nickel,
And we're doing fission right now, right?
and I'm going to say this nickel, yes, we're doing fission.
Okay.
This nickel, I'm just going to say, I'm going to make this up. This is going to have 75 as its overall mass, right? Plus something we don't know
Where'd
yet.
you get 75? You made it up, right?
Yes.
Nice.
You
Totally
should've
just said
said
that.
it was-
I totally didn't hear it.
Totally said that. Okay, there we go.
Why are you making so many neutrons?
Because
Because
I
he
felt
wants
like
to.
it.
Could you have put 2 if you
I
want?
could have, but in this example, I chose not to. I chose 3.
Okay.
You want to find that?
Yeah.
Okay. Now, how do we solve this problem?
I know.
Oh,
It's again, it's like this whole little
Can I do the
algorithm.
bottom first?
6 equals 75.
okay, so
Goes to the bottom.
92 is equal to, because it's all zeros, it would just be 92 equals 28 plus x.
Equals 28.
Plus x, because it's all zeros.
So those are all zeros, so you just decided not to include those in the little.
Now minus
Equation.
28 from both sides.
Yeah.
That's 70 something or 60 something.
What is it? We gotta actually be
68, 64, 62,
Just
64.
guessing.
64, 64.
Now you're making me angry.
No, 64.
Really?
64.
Yeah, 64.
Good job, Mark.
Thanks, Mark.
Takes. See, Mark's strategy is to avoid as many numbers as he can, so that way he
Oh.
can say, "I told you I was right."
Low battery.
Yeah, I know. it's good.
You're actually good at mental math.
So,
Where's 64?
64 on the periodic table. Where the heck is that? It's on 64.
Oh yeah, how do you find
Mr.
On
San,
the top on that one.
instead of writing out all the neutrons, you could
It's
just put
down
like
below. It's
No, where is this at?
GD.
64.
Okay.
Okay.
Right?
It's a little
GD.
bit-
GD's not on this chart.
Yes, it is down below.
It's like Guido.
On the top,
You know?
it's 235
230.
plus 1 equals 75 plus x plus 1 plus 1 plus
Oh!
Is it like 311 or something?
So on this side, it's 236 equals 78 plus x. So now
Oh, minus 78
Oh,
both
never
sides.
mind. It's not even 300. It's like
78, that's
Like
gonna be
314.
236.
158, 158.
178?
I added.
Oh,
I
that's
added
right,
75.
that was sick.
I added 76 and
Wow.
235.
Bro, me and mental math, we don't have good relationship.
Good.
I have no idea.
Very good. Okay?
Mr.
That's
San?
how you solve a fission.
I
That's so
honestly don't know.
easy.
Critical mass. Let's talk about critical mass right now.
Wait.
Real quick. Real quick.
instead
real quick.
of writing all the neutrons out, you could just put like a 3 and then an N
Put out,
and one
yeah.
O, right? Okay.
Critical mass. This is all critical mass is. Critical mass is the mass needed for a chain reaction to keep happening. That's it. Mass needed for a chain reaction to keep happening. So if we
What
got less
mass?
than that, it's like the dominoes, right?
Wait, say it again, a critical mass?